To properly install uAim, go to your Epic Games Launcher and to your library. And if you scroll down, search here for uAim and install uAim into your engine. So that's the first thing you have to do. And then the next step is to activate the plugin. And for that, I'm going to create a sample project first. Let's pick the latest Unreal version. To do that, and for the showcase purpose, we are going to use the third person example. And this one is going to be for Blueprint. I'm also going to show you how to integrate it on the C++ side, because there's also an interface to use uAim with C++. But first, let's do it the easy way with the Blueprint showcase. So let's create a project. Let's call it third person Blueprint tutorial, and let's create. So here we are in a new project. It's the third person template, and to install uAim or to enable uAim in this project, you go to Edit, Plugins, and you search for uAim, enable it, and restart. So for the Blueprint part of things, that's basically the installation process. So if you open this up, if you go into your content browser, let's make it a little bit bigger, make sure you have here show engine content, show plugin content. I also have show C++ classes because I do some C++ as well, of course. And yeah, you need this too to be enabled. So you see the plugins folder, and if you scroll down, it's very down. Here, this uAim content. You can go to demo, for example, and maps, and you can open the demo map. And that's basically the showcase demo. If you press play, everything is already set up, so these things work. You can also use the lock-on feature, and you can also use the mouse to move this around. So this implementation has been already done. You can also press R to have this different view, and yeah. So that's the tutorial for how to install and enable uAim in your project. And the next tutorials are going to be how to create a basic setup in Blueprint and how to create a basic setup in C++. Before we dive into more specific details, let's go through this getting started kind of video first. So I'm going to create a new project here. And it's going to be a Blueprint project. I use the third person controller, and let's create it. So here we are in the project. Let's open the plugins folder. Let's search uAim. Let's activate it, and let's restart. So now that we have uAim enabled, make sure that you have here show engine content, show plugin content activated as well, so that you have this engine here and plugins here, and scroll down to uAim, demo maps. Let's open this maps. Then you got the demo content in here. If you press play, you should have the same thing as from the demo. This turret should shoot at me. I should be able to target these things and switch the mode as well. And if you have any lags when you press play for the first time, and it's due to Unreal loading some stuff, so it can take some time until these lags disappear. If you have it, I don't know if you will have it. I had it a couple of times actually since Unreal 5. I don't know why. But yeah, it's nothing dramatic. It will disappear. So that's the demo. And yeah, if you want to use content from that, for example, if you want to use this turret here, We can select it, browse the asset. Then we got it here, right? And this turret, all these turret systems, even the tank, they derive from this class here, from this empty base class, which means you can just copy it from here. So let's take this turret, maybe take this as well. Let's take these two turrets, the one with the second one which shoots homing missiles, and let's go to here, blueprints, and just paste it here. So we got them into our main project, and they are going to work just fine because they still derive from the right class and have here their own settings. And to see the settings, because you don't see it like that by default, show inherited variables. If you enable this, you can configure your own settings here. So let's compile and save. Let's compile and save. This got it automatically. Yes, so with this too, we may also want to have this here into our main project. So browse the asset, that's that. Copy, go to the main project, paste. I just compile and save. I don't know, I have this automated. And now we can go to the map. And inside here, we take this detector and we take this turret, for example. Make it a little bit bigger. And we have to rotate it. And on this detector, we can select the turret. So we press the pick button and select our turret. And actually, if we press play now, this is by the way, this character controller is the default one. It's not the one from uAim. It's just the third person character, the default one. And it still reacts. But if you see, the projection of the color also is applied on the character, which doesn't look good because this is a projector. If we open this, we can search for decal, receive decals. We can disable that, compile, and now it should not project on our character. Yep, now it's fine. And this thing here shoots at us, which is also fine, but it doesn't collide. So we have to fix this as well. So let's open the character and the mesh. And let's check for collision. And let's change this to custom. And visibility we want not to ignore. We want this to block or overlap. Both should be fine, I think. Let's put this here. And now it should hit us. Yes. Now it hits us. So we got this working pretty quick. We can also change the color of that detector by clicking the decal, and then you can change the color to something else if you like. We can duplicate this, again another color, and we can take this one and select. Why doesn't it select it anymore? Something's weird. For what? It's an Unreal. No, this is an Unreal bug. Let's remove this again. I don't know what happened there, but it didn't duplicate it correctly. Because I am an idiot. I duplicated the wrong thing. Let's duplicate the right thing. Sorry for that. And now we can select it and change the color of the decal. So if you select the decal, it's only going to duplicate the decal, obviously. So you have to select to move back to this and then again. So you're moving the right thing. Because I changed the color, it created this issue. Sorry for that. So let's pick up another turret like this one. And if I go here, this shoots with the homing projectiles at me and this with that. So that's basically the quick start to get objects up and running. And what you can also do if you want this to react to something else, you see you can select an actor. For example, I can just select this here if I want to, and then it will automatically shoot at this actor, at this target. And let's move it a little bit here. And the same I can say with that. I can select this and then it will shoot at it. Now they fight against each other. But as you see, the origin of that is on the bottom. It's not very nice. That's why we have real targets somewhere. Or actually you can also create whatever you want, an empty object and let's do it. Or no, before we do that, I think it's easier and better in this getting started if we just take some content or some more content from here. So in the demo, there is blueprints. Where's blueprints? No, here, blueprints. We can just get this actor and place it here, for example. And I can place this at this position, for example. And I can say, I mean, it's already configured that it's invisible as far as, no, it's not. Then we have to tell it to be invisible. Here's a hide sphere in game, just press this button and now it should be invisible. Yep. And since we have this new target here, we can select that and we can pick the target instead, and then it's going to shoot at a different position. And what I did before in the other map was to just parent these things together by taking that and this and just drag and dropping it there. So for example, if I move that, the turret will move as well. This works in the editor for placement, but it's not. If this is a movable object, you will need to attach this to that in addition. And this is what I did, for example, for the tanks. So you can check out the tanks if you're interested in doing stuff like that. And we also have movable actors that we can place here. Let's say this one shoots at the movable actor here. And we get this also running. And because we have this also enabled here, if I run here, this thing is going to shoot at me. If I run outside, it shoots at nothing, because this triggers, that's the logic of the trigger, which says if something runs inside, shoot at it. And if the same object runs outside of the trigger, stop shooting. The same for that. And then both stop, obviously. Because that's just the logic of the trigger. You can use your own triggers however you like them. Yeah, that's basically the getting started to get some content into your project. You can also copy all of that stuff here that you want to use into your project and modify it. For getting started, I think this information that I gave you is enough, and the next video will be about getting the target feature or lock-on targeting feature on the character. So here we are back to our previously created project. Let's open the third-person character. Here we want to add the lock-on feature. So I'm just going to create an input here. It's dirty. I know it's not using the enhanced input with the started, but instead it's just the key directly with the pressed. But this is how we are going to do it in this tutorial. But if you do it in production, please use the enhanced input. It's better than that. Anyway, for this tutorial, it's fine. And yeah, we first add the component, the uAim component, press add here and search for uAim and uAim lock on. So add this, let's compile and save. And when we press F, we want to lock on to a target. And if we press F again, we want to unlock from the target. And to do that, we are going to make life easier than it has to be. So if you remember in the previous tutorial about the installation under engine plugins, if you scroll down to uAim content, there's demo, there's also a blueprint folder. And in here we have the uAim third person character controller, and with that, it has a lot of features, I know, but we don't need most of this because in this tutorial we are only going to add a simple lock-on functionality, which means it's exactly in here. You see lock on, and it's exactly this here. Oops. It's exactly this here. So we copy this, and now you have to be a little bit cautious because if you paste it here, it asks some stuff, and everything is red. So we don't want that. So let's remove this. We do it differently. And the correct way to do it is to see what functions we are using here. And there are two functions being called from this class, from the character class itself. So let's copy these two classes. One is this one, compute rotation that handles offset rotation, and paste it here. Then we copy this one, which is that, and paste it again. So we got both functions here, and now we can copy that and we paste it here. But we have here three parameters, so let's copy this as well. Offset rotation, and look to target fade-in duration. Let's copy this too. And the third one is auto lock interpolation. Oops. Why isn't it copying it? I selected the wrong one. So now we got it. I'm going to explain some of that, but first let's compile and see if everything works. This looks fine. Before I explain what's going on here, let's first try to create a sample where we can look at something. So in here, the class that we want to look at is of this type here that is configured here. You can configure any type you want. So if you want to create your own targets, you can do so. But I just use this one. It's a simple one from the uAim content project. If you can have a look at it, nothing happens here. It's just a ball basically with some UI and a function where you can set the visibility of the UI widget. That's it. It's basically just a very simple actor. Yeah, but you can create anything you want and you can configure anything you want in here. But for testing or for creating that, I put it a little bit up because otherwise it may be colliding with the wall, with the floor, and because we have collision here enabled, it must see this thing here, right? So let's put it here, and like that, it should work actually out of the box. And I don't know why my editor is lagging. Just a moment. For whatever reason, my editor is lagging. Now it's fine again. I don't know what this was. Anyway, the lock-on feature is here, but this doesn't look good because we have the boom arm in the wrong position. It's a very bad position where it is right now. So let's move it. Let's put here 250. Here maybe 60. Maybe that's too much. 50. And here maybe 60. or 70. Let's compile. Let's see how it looks. Yeah, it's fine. So I pressed F now. Local is on. Now it's off again. On, off. So I can look around again. On, off. On, off. So that's how to add this simple lock-on functionality. I almost forgot, we need one more thing to handle, and this is the camera input. So actually we do not want to apply camera input if we have lock-on, right? So if we have lock-on, no camera input should be applied, only if there is no lock-on. So let's move this out a little bit and let's paste it here. And let's say if we have no lock-on, we can apply this. And otherwise we can't. So if we have lock-on, we cannot apply that. So this is to block camera movement when having a lock-on target. Yeah, that's basically this. And yeah, you should add this as well. So now let's continue. Let's get through the code a little bit. So here I check if we have a lock-on, and if we do, and press F, we stop the lock-on. So this we don't even need in here. So we can do it like that. And this here corrects the orientation where we look at in regard to the offset rotation, because we can have some offset rotation. I'm going to show you what's an offset rotation. To understand that and why we need this, we would not need this if we wouldn't have an offset rotation. So let's see what we can do with offset rotation. Let's apply here some offset and here some offset. And then we will see that if we target it, it's off center, right? This is not in the center of the screen. And that's what this is being used for. And yeah, this is useful if you don't want the target to be in the center, but to have some offsets. And this is why we need this here to correct for this offset to capture the correct target, right? Because you would target on a different center on the screen. That's why you need that. But usually most of you will probably have 0. But yeah, this depends on your game. The lock to target fade-in duration is the time it needs until it fades to the target. So let's see if we put here 1, for example, it's going to be very slow. So if I press F now, you see it takes some time. And the auto lock-on interpolation is at -1, which means it locks onto the target very directly, very how do you say it, like a lock-on. It's fixed, right? After it made the transition, it's fixed at this position. But if we say, for example, 10, we have some interpolation enabled. -1 disables all the interpolation. Now we have some interpolation enabled. So if I move now, you see there's this lag behind, this small amount of lag behind. But if I put 3, which is very low value of interpolation, you see how it lags behind way more now. And you can use this to smooth out the movements. And yeah, you can create some nice effects if you combine these 3 together and have some nice lock-on functionality. Yeah, so that's it for this basic setup for Blueprint. And the next tutorial will cover a basic setup for C++. So in this tutorial, we are going to enable and configure uAim to work with C++. So let's get started. So we got this C++ project here. We take again the third person sample or template, third person, C++ tutorial. And let's create. So here we are in the new project. Let's enable the plugin first. So we search for uAim, edit plugins, then this window opens, we enable uAim, and then we restart. So we can actually close the project now after the restart, because we have to enable uAim in the C++ project, which is this one. And you have to open this file here. So it's under uproject, source, uproject name. For me, it was called like that. And then open this .cs file and write this. That's what you have to do. You have to write here uAim, comma, and then uAim. So let's save this, then close it. You don't have to compile here. You just close it. Then in your project, you remove the intermediate, right click, more options, and then generate Visual Studio project files. And now let's open the project back up, the solution, to have it in C++. And now we can use it. So let's try to make the first example project, the one that we did in Blueprint before. We are going to do it here as well. And in this project, because it was generated from a C++ template, we already have the character controller. I think it's the character controller.h file. We can close this, we don't need that anymore. And then there is the CPP as well. So these are the two files from the character controller. There's some issue with the highlighting, but we only have to wait a little bit and then the highlighting will appear. So what we need now and what we can now do is we can, in the CPP file, include uAim logon.h. This is what you need, not this one. This one is what you need, okay? And now we have to configure the logon, so we need to do something in here as well. This is the default setup of the third person controller, so we make some empty spaces here. And now first we need the component and create the component and save it as a member variable. And to do that, I just copy that here, and instead of follow camera, we say that's uAim, and then category, we say it's uAim, or actually we can say that's a category components. So you can use this category for all your components, or maybe you have something else in here. And here we have uAim log on. And that's class forward declaration, and here we write uAim. Okay, that's the beginning. We need an input action as well. So that's what, let's finish this first. Let's do it here. uAim is create default subobject, uAim log on. So now we created it, like these other things are being created. I don't know how well you know the C++ side of things, but I guess you know it, because otherwise you wouldn't watch this tutorial probably. So we create the uAim component here, and now we need the input to trigger it, to lock the camera onto a target and to unlock it. And for that, we take the jump, just copy paste it. I paste it here and say that's log on input, log on action, and category is input, that's okay. And we go back to the CPP where the binding happens, and we take this here from the jumping and we say log on, and we bind the log on action to the log on function that we also have to create. For that we take the same as the jump. I just, oops, where did it? It calls it directly. Sorry, this we can't use it like that. But we can create the function here. So I just take the look instead, if that's the case, and here we write log on, and we generate it. So now we got the log on function here, and I think that's wrong. We need to use this, and now we can jump here. All right, and now let's write some code. If we have no controller, we return, and now we need some logic to switch between a lock-on functionality and non-lock-on functionality. So if we have lock-on, we say stop lock-on. Okay. And if we have no lock-on, we have to say start lock-on. Okay. But this needs some input, and this input we have to compute now. And we have to find the target first, right? So if you want to lock your camera on a target, you first have to find the target. And to do that, there's a built-in function also into uAim that we are going to use now. But usually you write your game-specific code to do that. But this function is still super helpful, and it's easy to get started. That's why we are going to use it. And to use that, it needs a class that we are going to search for, which then we will find the best match and log to the best match. And for that, we need here a subclass of an actor. And we say that's our log on target class. And this also has to be a u property of edit anywhere. So we take this, and if this is not set, we return, because we need this class to be configured so that we can use it. And the function from uAim that is going to return a actor is called uAim find best look at target, and here we need this class. But that's not everything. We need some other stuff, so like a source location. And the source location in this case is the follow camera get component location. The direction is follow camera get forward, and we want to trace, to line trace, to check for visibility. This we want to do here, and collision channel is going to be camera. So we want to check if we collide with anything that is in the camera channel. If you want, you can use other collision channels as well, like visibility. Most tracing is actually done in visibility, but in here we are going to be fine with the camera, because this function, if it does not hit anything, it's valid. So it's invalid if it hits the wrong things, and it's valid if it hits nothing, because you can have a target without a collider at all, right? And if that's the case, then you don't want to hit anything, because this target has no collision at all. And yeah, you just want to exclude with this function anything that is the wrong collision. That's why we can use easily the camera, and we need some blocker channels. And let's create these blocker channels. These are, like I tried to explain, the collision channels that if the line trace collides or traces such a channel, it's going to be invalid, because there's something in between the player and the target that you want to lock on, or between the camera and the target that you want to lock on. So let's create a array, and here we need a spite and a collision channel, and these are blocker channels. So you can have multiple blocker channels, of course. And we say blocker channels, add, and we want in this case to have the collision channel for world static as a blocker. And just that in this case, okay? And let's copy this. And that's the blocker channels. Trace complex, we want files. And there are some actors to ignore, and we want to ignore ourselves. So let's create a T-array actor. Actors to ignore. And we add ourselves. And then we take this and put this at the end. And I think that's the last parameter. Yeah, that's the last parameter. So we got an actor now that we want to track. So we can say we want to lock on the camera to the target. We want a fade in duration, for example, of 0.2. Offset, we want a vector 0. And what's next? We want raycast 1. That's how many raycast iteration it does, because for the players there's a built-in functionality with additional raycasts to make the camera collide when it rotates towards the target to have a better result. And one is usually enough for the player. And interpolation, we want -1, because we don't want any interpolation here, just a fade-in interpolation. And to the auto lock-on, if you look at that, we have the fade-out duration of 0. That's also completely fine. You don't need a fade-out duration for fading out. You don't really need that. So actually, that's the code that you need. So let's press play now and see if everything works. And if everything compiles now, we will be able to lock on targets, on specific targets in the game. So here we are in the game. Let's open the blueprint of the third person character. Open full editor. And here we need to configure something. The input is the first that we need to configure. So we have no input. Actually, we do have the logon from the plugin folder, if you look at that, but this is not what we want to use. We want to create our own here. So in our inputs, we go to actions, just duplicate the jump, and this is our lock on that we are going to use. from this project here. And we also have to configure the mappings, log on, and we use the one from the project. And we need an input as well for that. I almost forgot. Let's choose F. So let's save this. This also, let's save all to have this saved. And in here we say our input action is the logon. And make sure you select the correct one. That's the correct one. And save. And we also need a target class. So actually this can be any actor class, can be configured here. We can create our own. And I think in the blueprint tutorial I showed how to use the built-in target class. But we can create a new one as well, just to show this too. Let's call it BB target. And in here we say the BB target is our target that we are going to try to log on. But we need some visuals for this as well, so we see it. Let's add a sphere. Let's make it a little bit bigger. And let's save. So we got our sphere here. And we move it up a little bit so that it's the center, because this is what we are tracing against. The center is not below the ground. This would be bad because it could create a collision with the ground, and then you would not be able to see this object because you have tracing enabled. So let's see if it works. And here we are, it works. And now I freed it up again. But I, again, here don't like the camera boom arm setting. So let's configure this a little bit. I think we had 250 in the other tutorial. Is something like 50. And here probably something like 65 or so. Let's save. The camera looks better now. And if I press F, boom, it locks on the target. And yeah, through that, thanks to the tracing, if you look at this, now my camera collided with the wall, but it's still tracing the ball, right? Even though it collided with the wall, which would otherwise create some issues. But thanks to the tracing option that we had there, this is going to work. And yeah, that's this functionality. And yeah, with that, you got the basics running. And what this doesn't have, that the blueprint one had, was support for this offset rotation. For that, we would need to write some code. So I think, yeah, why not? Let's write it. Let's write this additional code to have support for having values as the offset vector as well. And we are going to make life easier because we are going to open engine plugins. You have to enable this too to see that. Plugins, uAim content, blueprint, and our third person controller. And in here, there's this function that we need. And yeah, let's see what we do here, because we're going to port this to C++. So we get the follow camera world rotation first. So let's do that. Let's do that. And actually, we need it before find best target. So somewhere in here, follow camera, get world rotation, not set, get component rotation. That's the world space, I think. In world space, yes. So we got the rotation. Let's see what's next. And we multiply the rotation with the inverse of this vector. So x is roll, y is pitch, and z is yaw. So let's create this rotator now. So let's do it here. So it wants pitch first, then yaw, and then roll. And pitch is Y, which means we are going to create an offset rotation vector, which is going to be in X, that's the roll, 0. Pitch is going to be 15. And yaw is going to be 30, or let's say minus. I think these are better values. So we created this offset rotation, and we are going to use this here. You can make this a member variable that you can configure if you want, but I'm not going to do this here in this tutorial. I just defined this offset rotation, and then in the end you're going to see what this even makes. What's the difference between having an offset rotation and having no offset rotation. So we defined it here now, so we can say here we want first, I think it was pitch, yes. The pitch is Y. Yaw is Z, and roll is X. Let's see once more. And let's compare it here as well. Roll is X. Roll is X. Why doesn't it show? Doesn't matter. I think it's right anyway. Y is the pitch. This should be the pitch, and then that's a yaw. This should be fine. So we take this rotation and we say our look at rotator is, what did we have here? This multiplied with this inversed. This multiplied with, no, wrong. Complete wrong. It's this multiplied with this inverse. We need here also quaternion, otherwise this doesn't work. And then we transform this to an rotator. And then instead of using the forward direction, if we look here, how this is being used, instead of using the forward vector of the camera, we use get forward vector of this rotation. Oops, let's open this up. So we replace this with look at rotator. Oops, not this punkt. Yeah, that's the function that I wanted. So this should enable offset rotation now. And because we did not make any changes to the .h file, we can safely in here compile with this live coding feature. It is usually fine if you don't change anything on the .h file. So this worked. So let's see. If we press F now, you see it's off-centered, right? Our target is not anymore in the center, but it's on a different pivot on the screen, basically. And that's what you can do. With the offset rotation, now I disabled it. And yeah, that's this feature. If you want to use that, make this a member variable, and with a code like that, you have support for offset rotation as well. And one more thing, if we put here a value of 2, for example, for the interpolation, just so you see that's the interpolation factor. So -1 means there is no interpolation, it's ultra quick as possible, and any value bigger than 0 has interpolation. 2 is very little, 20 would be very fast interpolation, for example. Let's use 2 here to show this off, what this does. And you see it has this lag behind effect on rotating towards the target. So that's what this effect does. It can smooth out the movement. And there's one issue. You see, even thought that I'm locked on, I can still use input and then it goes back. That's an issue that I almost forgot to cover. That's because both inputs are being applied. First of all, because this is very light, this is applied very lightly, thanks to the interpolation value. It gets the new input, which it gets from here, from the look function, and then you apply both, which is not good usually. If you want a lock-on, you don't want your camera to move when you move the mouse, right? Which means in here we say if uAim has lock-on, return. We don't want to apply anything if we are locked on. So let's try again. And now I can't move my mouse anymore. It's not possible. So it's always on the target, even though we have this delay. And if I stop locking on, now I can move my mouse again. So this feature I almost forgot to include in here. And yeah, that's it for this tutorial. I hope you liked it. And the next tutorial is going to follow. In this tutorial, I'm going to explain you the core functions of uAim. And I don't know if I've mentioned it, but uAim, the core of uAim is basically this component here, the uAim lock-on component, which you have to add to any actor that you want to use it on. So let's get through the functions. In all the examples, I'm using the auto lock-on mode, which means you can use start and stop to enable and disable the lock-on feature. This is very handy and very useful, and this is what we use for lock-on, but there could be cases where you don't want this, where you just want the correct rotation, the perfect rotation to be returned, and then you want to do whatever you want with it. Like, for example, if you want to implement some aim assist where you don't lock on the target, but where you just use it as an aim assist, just something that helps you to aim at the target, for example, very useful for controllers, then you have to call this function here and then do your own logic how to apply or how to use this rotation. I have done exactly that in my own game in Captain Carnage to implement the aim assist system of that game. So this is how I use it personally, but I gave this feature to you, but most of you are going to use this. These functions, by the way, also call this function, of course, because this is just how to acquire the raw perfect rotation to view the target. And here you stop it. You can set some parameters after initializing the start. here, this is also going to be very useful. Has lock-on is super useful because sometimes you want to check if you have the auto lock-on mode enabled or not. So of course, these functions here are for the auto mode. And this is also a very, very important function because, for example, for a turret or for a tank or whatever, you have to initialize your own system, which is not a player camera, right? Because the auto mode, if you do not call this initialize function, usually finds by itself the camera or the camera boom or spring arm. Actually, it's the spring arm component that it searches and finds, and also the controller of your character to apply the rotations or to compute the rotations and then apply it. But for turrets and all this, you have a different system, right? You have a system which has a yaw component and a pitch component and an arm component, or it may have. The pitch and yaw can be the same. It doesn't have to be two different components, but usually it's two different ones because you have different origins from where to rotate to look at the target. And yeah, the arm is basically the thing that is stretching out. I don't know how to explain it any better, and that looks at the target with its forward vector in the end. So you still have pitch and yaw, yaw and pitch for the rotation applying the rotation. And then you have the arm that is extended that actually has to look at the target. So this is how this system works. It's like an IK system actually, but for rotations and not for movements. This function you usually should not use. It's a very risky function to use, to disable it, because disabling this can lead to a lot of issues in edge cases, because the algorithm internally switches between different algorithms to have a smooth behavior also in edge cases, like when you are very close to the target. The perfect algorithms don't work well when you are close to the target. They create weird behaviors. So you should not disable this. Don't call this. I put it there so you could do it if you really need to, but I do not recommend to do that. Not at all, actually. But it's still there. This is for target prediction. So it predicts the movement of the target, where it's going to be next. If you need something like that, that's useful for turrets. It's not useful for the player. You can also apply some random continuous behavior. I don't do that in my examples, but the function is still there. Just make sure that this is small. This value is small, because otherwise you are going to have bigger movements from one offsetted rotation to another. And with the angle in degrees, you can set what's basically the max value that your offsets can be. What I use in the samples actually is this function here, the one-shot function. In my opinion, this is a better function to use, because when you shoot, you apply the offsets. You know what I mean? And then it goes back. So it has an apply duration of the offset and a return duration. And I actually use this for the animations of the turrets and the tank too. And it works pretty well with different settings than I chose, because in my settings I have some math that I do so that it returns quick enough so that it has no offset when you shoot, at least not for the turret. But it can have an offset for the projectiles, because I additionally compute some offsets for the projectiles that I then apply. So there are two different random offsets that you can apply, one for the turret and one for the projectile after being shot. This is also very important for turrets and tanks. You usually want to have the interpolation mode to constant. There are two modes, a normal slurp and a constant slurp. And for turrets and the likes, I absolutely recommend to have the constant slurp instead, because it's just smoother. For the player, I don't recommend this option because it can create behavior which you may not like it takes too long to reach the target like that. So for the player, I recommend to have the default interpolation method. These two are for the prediction. So the prediction that we started previously with, which function was it? I'm lost. With this function here. If you enable prediction, you can set some other settings here. I personally recommend to use more this function, because this function basically smooths out the velocities and interpolation. The velocities and acceleration of the movement of the target, which makes your turret to react with kind of a delay or with a smooth motion. And this is more for the adaptation. Like if you compute a new position, right? You have to update to this new position. And I do this in a relative space, which means it's always an offset from the real target that is being used. I don't necessarily recommend to change this. I would focus more on that, but you can play around with both values if you want. I think you can configure both in the turret systems anyway. Here we have some other useful getters that you can use. And there are also some general purpose functions like this find best look at target. I do use this in a tutorial for the C++ kind of C++ world, actually, to create a quick behavior where you can look at a target. With this, I can find the target that I want to look at. And this function is also implemented in Blueprint, and it's being used in Blueprint 2. But it's the Blueprint version that is being used there. So you can, for the people that use Blueprint, they can check out this function and make edits to it if they want. Because sometimes, or most of the time, you have a very specific game, and depending on your game, you want to have your specific logic, and you want to do your own find best target, And that's why I implemented this function twice. Once in C++ and once in Blueprint, and everyone can change it wherever he wants and modify it to his own liking. These functions here are more core functions to compute the rotations. These are also being used at the top by this function here. You actually don't need these functions, but you can use them if you like or if you want. These are very low-level functions, actually. This is also part of the computing of the rotation on a low level. And we have some clamping functions. And here we have some other low-level functions that you can use if you want, but yeah. Yeah, actually, that's the core features of uAim that you can use, of the uAim component. Of course, uAim comes with a lot of examples that you can use in your games as well, like the already implemented turret systems, tank systems. So use the stuff as you need or as you like. I hope this is going to be very helpful for you. And yeah. While uAim doesn't officially support lower versions of Unreal than 5.4, so for example, 5.3 is not officially supported, you can still use the core component of uAim in lower Unreal versions. And this is what I'm going to show you right now, how to do it. However, you are not going to get any of the samples from the uAim system that I included in the package. You are not going to get those. You are only going to get the uAim lock-on component, which is a component implemented in C++. This is what you are going to get if you want to use it on lower Unreal versions. And you can still do the same things. It's not restricted in any way. It's just that the examples will be missing, which means you have to implement your own stuff with or by using the uAim lock-on component. And yeah, I'm going to quickly explain you how I use it, because actually in my personal project, this is exactly how I use uAim. So in Captain Carnage, it's still on version 5.3 of Unreal, and I still need uAim, but I implemented the examples, right? And this is why I don't need the examples for myself, That's why I only need the uAim lock-on component anyway. And to do that, you have to go into the right folder where the asset has been downloaded, which is this folder here, and you copy the asset, you copy uAim. This is the content of the folder. You copied that, and then you go into your plugins folder of your individual project. I did this already here. I pasted the uAim here, and I already got the binaries and intermediates. You have to remove this, okay? So just delete this and then compile your project. And one more thing, you have to change the version of that to 5.3.0, for example, in my case, because otherwise it's always going to shout and scream that it's the wrong version. And that's why you should do this as well. And yeah, that's what you have to do. And then you can compile it. You can use the component like that in Blueprint, but if you want to use it in C++ as well, like I want to, I'm using it right here for my aim assist system. And yeah, this is just one line of code, more or less. Not exactly. There are, of course, more line of codes in this character controller script. But yeah, this is the line where I need the perfect rotation. And yeah, don't forget, if you want to use it in C++, like I use it to enable uAim in your build.cs file. Don't forget that. Only like this you can include it and use it correctly and properly. And yeah, that's exactly how I use uAim in my game, in a lower Unreal version than my own system actually supports on the marketplace. But yeah, this is how you can use it on lower versions as well.